Introduction of what's going on here. So this is structured like a CTF because I always face the same problem in all my classes, which is there are many different people at many different skill levels. So a capture the flag format is the general solution for that. So you can skip over things that are too easy for you and move on to whatever is interesting to you. So go to samsclass.info in a browser on any network and click Intro to Exploit Development here. And you'll get to the page. There's a place you can submit flags and a scoreboard and the challenges. And I'm going to describe it in overview here, and then I'll do detailed demos of the most important ones as we go ahead. So we're going to start with command injection, which is the simplest vulnerability to exploit. And I must say, it's more and more common, especially now that we have machine learning. Almost all of those are vulnerable to command injection, all large language models. It's a very common problem. It is, at first it doesn't sound reasonable, but the point is data that comes from the user, like a username or a password or a file name, is misunderstood by the server as a command. And that turns out to be surprisingly easy to do if you're a sloppy coder. And the main thing that causes it is if you use code to create code that is then run in a different language, which is something a lot of sort of sloppy coders do. So anyway, if you have that problem, then you get ability to execute commands on a remote server. And so there are some projects here where you learn your command line Linux if you don't know it, and then several servers you can exploit with command injection. And so first we'll do command injection where you have bash command injection, you just execute Linux commands, then command injection in SQL, which is just another language, and Windows, CMD, and then a couple of other ones like server-side template injection where you have to inject in yet another language. And all these are the same fundamental flaw, but the language you're injecting is different. And then we're going to get into binary exploits, which I think are really the meat of this. We'll start with Linux. You get a Linux machine running, you compile some vulnerable code, and then you exploit buffer overflows and format strings and heap overflows and race conditions and in 32 and 64-bit Linux. So you get to see how that looks. And this is where you learn to do binary exploits, where you're injecting binary data, which appears to be a string as it's going in, but is later interpreted as executable code and run. And that exploits the fundamental problem with Windows, which, by the way, is a questionable design choice. We could have had a byte, and people have proposed this, a byte that was 10 or 11 bits. So there were some extra bits in every byte to indicate what type of data is in there, but we didn't do that. So everything uses bytes, and the same bytes are used for text and code and images and movies, so you can confuse your computer about how to interpret that stuff. And that's the binary exploits on Linux, and then we're going to do it on Windows. You get a Windows machine of some kind, and we'll run this thing called Vulnerable Server, which is an open source product that has a whole bunch of vulnerabilities, and we'll exploit that, again, injecting executable code, and we'll talk about some of the Windows defenses and how to overcome them. And then, this is Linux on Intel, 32 or 64. This was Windows on Intel, 32 or 64, and then we can do it on ARM. If you have a Mac M1 or M2, you have an ARM system, but if you don't, you can run an emulator, a QEMU emulator. You can just download an Ubuntu image I've got that emulates ARM, which is good enough, and you can learn how to exploit ARM systems. And I've been following with great interest because I really like ARM. I got a Mac M-ARM as soon as I could, and ARM is in financial trouble. The company is trying to go public, but they don't really have enough of a business model. So they were talking about drastically increasing their license fees, and people were freaking out and saying that'll kill it. And then last week, they got a reprieve. Apple and Amazon said they're going to pour a bunch of money into ARM. So I guess they both love ARM and want to keep it going, especially Apple. Apple has obviously already started making a big investment in ARM, and they don't want ARM to go away. But anyway, for a while it looked like maybe ARM would price itself out of existence or incompetently drive themselves out of business by not running the business well enough. And so the alternative would be RISC-V. And so I made a RISC-V exploit. You can exploit RISC-V. It's very much like ARM, but you can run a RISC-V emulator and see how to exploit that. Now, right now, you can't buy much that's running RISC-V, but if ARM was to become too expensive or unpopular, RISC-V might be the alternative. And then you can have some projects where you can practice assembly language programming if you want to get better at your assembler, because all these binary exploits involve injecting raw binary code, and the way to understand raw binary code is to just get it into assembly, which is intended to be human readable, although it's not all that human readable. And learning to do assembly language coding is valuable if you want to write your own shell code. And another thing that's important is Rust. If we all just switched to programming in Rust, all of this would stop. All these flaws are caused by the language C. C is written to be very close to assembly code, and it runs really fast, but it assumes that you actually understand the hardware and you understand what's going on when it creates a thing called a string, but it's really not a string, it's just a byte array, is the more modern term for it. And the early developers thought that would be okay, but what turns out is a lot of C developers do not understand exactly what's happening when they write C code. They assume that a string is like a string would be in like Python or a modern language, and it's not, and that leads to all these flaws. So you could argue that all these security flaws are caused by using an old-fashioned language that is just too confusing for most programmers to understand, and Rust is the answer. Both Linux and Windows are switching to writing the essential code in Rust instead, because Rust avoids essentially all these security problems. So I have a few projects where you can write C code and then write the same thing in Rust and observe how it fixes most of these security flaws. So that's an overflow, just to orient you so you can pick which one of these to focus on. And so when you do a project, like you get your Linux machine going, you need to do this. So get some kind of Linux machine going. It doesn't matter if it's Red Hat or Debian or whatever it is. You can download a Debian image if you want to, or you can use what you've got. And when you're done, execute this command and you'll find a flag. The part covered by green is the flag. You put that in. This is the ED 30.1 flag. So you go to the top and here you submit flags. So you find that challenge, which is here. You just put in your name and the flag, and then you'll end up on the scoreboard. I see a lot of people have done it. So that's the competition part. I should also mention, this is not like the real DEF CON CTF. These are not new challenges. They're not secret. They're not intended to be very difficult. There are instructions to help you. This is not in any way proving that you're super elite and winning a prize or anything. This is just a way to trick my students into doing homework. And the competition makes it a little more fun. But, in no way is it like a serious test of your awesomeness. And therefore, you're not supposed to find any of this too hard. If you get stuck, raise your hand. There's a bunch of us here to help you. So there are quite a few of us that are happy to help show people how to go through it. We're not intended it to be a very serious competition in that regard. So, all right, let me stop this record. I'm going to post recordings on this page. So if anybody comes in late or they want to review this stuff later, they can view YouTube videos here of all the things. And this will all stay up after the con. It'll go on my old classes page. Even the running scoreboard will stay up. So you can use this in your corporate training or for any purpose you want. So you don't need to take notes or anything. I will archive the scores after DEF CON just to record who won at DEF CON, but then I'll restart the scoreboard clean. But you can keep on looking at these things and playing with them as long as you like. So let me stop this recording.